Last video we have seen what a hub is and how a hub is going to help for multiple PCs to communicate to each other. What hub helps is basically you don't need to have multiple NIC cards for the same PC for communicating into multiple PCs, but all you need to do is one NIC card which is on the PC or the laptop, you will go and plug it into the hub, and all other PCs also will go and connect into that hub, and then the communication happens seamlessly. Now in this video, what we're going to see is a little bit in depth of how the hub works. We'll also identify some of the limitations and problems of the hub, and then we will get introduced into another device which is called as a switch. And we will see how the switch is actually helpful and how it eliminates some of the problems that hubs create. So let's get into first what hub is, or how hub is actually communicating a little bit in depth, so that we understand the problems of a hub as well. So here is a simple topology that we have come up with. There are 4 PCs connected, or 4 laptops connected to the hub, 4 ports of the hub. And now let's say PC1 want to communicate with PC3. So in this case, what happens is PC1 is going to send a signal to the hub because that's where it has been connected. And the problem with hub is it doesn't know any knowledge of where these PCs are connected. All it knows is there is some signal that's actually coming in, and I just need to relay it. What do you mean by relay? What I mean by relay is, with the moment hub receives a signal in one of its port, it is going to broadcast or send that signal or the message to all the other ports where there is some PC connected, because it doesn't have any intelligence of where the PCs are. Now what happens when these signals reaches PC2 and PC4 is they will drop these signals, or they will drop these messages, because it understands that the communication is not intended to me. PC3, it identifies that, oh, PC1 is trying to communicate to me, so now it's time for me to respond. Now what does PC3 do? PC3 sends back a signal because it's the message from PC1 was intended to him, and the message goes back to the hub. And remember, again, hub doesn't have that intelligence to store the information telling that, okay, in this port I am having PC1, and this port I'm having PC3. So hub again does the same thing. It actually does a broadcast of the message to all other devices that are connected to it, and PC2 and PC4 again receives the message, but it identifies that no, this communication is not meant for me, so it drops it. And finally PC1 also gets that, and PC1 identifies, oh, this is the response I got for the message that I have sent to PC3, and that's how the communication happens. And as you can kind of guess in this scenario, the problem here is unwantedly and unnecessarily a lot of signals and messages are actually broadcasted when there is a hub, right? So think about an enterprise network where there are hundreds or thousands of PCs and laptops connected in their corporate environment. So it's going to be a lot of flooding of the messages, and that's when we kind of identified there is a need of another device which we call as switch. The next video, we are going to learn how switch eliminates this problem of flooding of the packet, which is actually a problem that has been introduced by hub in our session here. We will see how switch is going to eliminate that problem, and how switch is able to learn about the PCs which are connected on different ports of the switch. So that's for the next video. Stay tuned. Bye.